All right, so we're going to have a short little video here about L'Hopital's rule. So for L'Hopital's rule, we're basically talking about the limit of a fractional function or of a fraction where we have a numerator function and a denominator function. And this limit would have values which are indeterminate if we tried to take it initially. And so that's the main setup for L'Hopital's rule, is knowing that you have these two potential functions in the numerator and the denominator, which might give you something which you can't find the result of initially. So a good example of that is having the limit as x goes to c of f of x equals 0 and the limit of x goes to c of g of x equals 0 when you have when you're trying to find the limit of x going to c of f of x over g of x. That would give you a limit of 0 over 0 if you tried to evaluate them separately. And so in that case, you can't actually take the limit without doing a little bit of manipulation to the function. So one potential way that you can do this is by doing L'Hopital's rule, which says that you can take the limit of x going to c of f prime of x over g of prime of x. And this operation allows you to change which function you're kind of taking the limit of while still preserving the overall limit as what it should be going to. So instead of evaluating 0 over 0, which is indeterminate, you'll be able to evaluate a more reasonable function. Now, for an example of how to do this, let's say that we're taking the limit as x goes to 2 of x squared minus 4 over x minus 2, which is this limit down here. This limit down here is a fractional function, or rational function if you would. And this rational function with a function in the numerator and a function in the denominator, which are polynomials, can have their derivatives taken fairly easily. So the derivative in the numerator becomes 2x, and the derivative in the denominator just becomes 1. This allows us to say that if we take the limit of this function, this rational function, then we can do x to 2, limit of x going to 2, of this 2x over 1, and that will result in 4. And if we look back at what the limit of the initial function was, the limit of the initial function would also be approaching 4, depending on how we look at it or not. And so one thing that we can do with the numerator of this part here is we could actually take x minus 2 out of it. We would get x plus 2 as the remainder if we divided this term out of this one, because of the way that the terms are multiplied in the numerator to get this. And that would mean that we have x plus 2 as the function if that discontinuity where the value doesn't exist at x equals 2 was removed. And so if we have x plus 2 is what the more general function would be, taking a limit of that would show that we would actually have a value at 4 if we were able to plug that gap that currently exists in this function. And so that just confirms that L'Hopital's rule works, at least for the value that we see here. It doesn't prove it for all cases, but it proves that it works the same for this case. And in general, L'Hopital's rule does work for all cases if you have this limit of x going to c of f of x equaling 0 and the limit of x going to c of g of x equaling 0. And so you can try it and you can see if your derivatives for the top and the bottom will actually give you a reasonable result out of it or not. And we can also check it with another example here, with this limit as x goes to 1 of e to the x minus e over x minus 1. This, if we take the derivative of the top and the bottom, we'll get a limit as x goes to 1 of e to the x over 1, which has a result of just e if we plug it in. And so this is another case that you can do L'Hopital's rule, and you're going to see what you get out and check it kind of with where the function is heading in terms of plotting it out and taking a look at it. This operation or this rule, L'Hopital's rule, also works if you're trying to take the limit to other values such as infinity or from the left or the right. And so if you're ending up looking for a limit in most of these cases, you can do this L'Hopital's rule to make things a little bit simpler on yourself. Also, if you're looking at it, you don't need to just have the limit of f of x equaling 0 and the limit of g of x equaling 0. You can have as an alternate case the limit of f of x equaling either plus or minus infinity and the limit of g of x equaling the corresponding plus or minus infinity. Both of those would potentially work. So, all right, that's all I want to say about L'Hopital's rule right now. So I'll go ahead and see you guys for the next section.